Hello everyone, we are Team Data Crew. Today we are here for Smart India Hackathon presentation. The problem statement we have tackled is student innovation. It is assigned by AICT Ministry of Education Cell. It comes under theme Clean and Green Technology in software category. The description provided by the organization was solutions in the form of waste segregation, disposal and improved sanitization system. India generates 62 million tons of waste every year. About 43 million tons is collected, of which only 12 million tons is treated. Rest is just dumped in the landfill sites. With changing consumption patterns and rapid economic growth, it is estimated that urban municipal solid waste generation will increase up to 165 million tons by 2030. So the solution to this problem, we are developing a system named Zero Waste System that aims to minimize the amount of waste generated. Our system focuses on 3R mantra, that is reduce, reuse and recycle, and it also works for composting system. The working of our system is such that users, whether individuals or establishments, begin by registering on the Zero Waste System platform, providing essential details such as their address and contact information. Upon registration, each user is assigned a unique QR code which is affixed to their dustbin. This QR code enables the system to accurately link waste contribution to each user's profile. To ensure effective waste management, users are required to segregate their waste into dry and wet categories prior to disposal. The QR code on the dustbin identifies the user and records the type and the quantity of waste deposited. This segregation facilitates accurate tracking and processing of waste. During scheduled routes, garbage collectors visit each registered location using a device integrated with the Zero Waste System. Collectors scan the QR code on the dustbin. After scanning, they input the amount of dry and wet waste collected. This data is then stored in the system's centralized database for comprehensive processing, analysis, and monitoring by the municipal council. Collected waste is transported to the segregation centers where it undergoes processing. Wet waste is decomposed to produce fertilizers, and dry waste is sorted into various categories for recycling. The recycling process generates revenue, which supports a circular economy model within the system. A portion of this revenue is allocated to the reward users based on the accuracy and consistency of their waste segregation, promoting continued engagement and sustainability. The reward system incentivizes users to adhere to proper waste segregation practices. Points are rewarded based on the accuracy of the waste categorization and regularity of disposal. These points are redeemable for rewards, encouraging users to contribute to the system and fostering a culture of responsible waste management. Our system also provides various features such as chatbot assistance. The chatbot provides users with support for registration, complaint filing, and answers to frequently asked questions about waste segregation and collection. We also have the grievance portal. Users can log complaints related to waste collection such as missed pickups or data related problems. The portal tracks this complaint until resolution, ensuring prompt attention and accountability. We also have the feature of the multilingual support, allowing users to interact in their preferred language. This feature enhances accessibility and promotes wider participation from diverse linguistic groups. We also have the educational tutorials and games. Interactive tutorials and environmentally themed games are available to educate users about waste management and sustainability. These engaging resources make learning about environmental responsibility both informative and enjoyable. The next we have is the technical stack. We are developing a system in integrated development environment that is Visual Studio Code. We are using HTML, CSS, JavaScript for the front end to provide a responsive and user-friendly interface for inputting details, viewing waste data, and tracking collection. We are also using Python with Flask for the backend to manage user registration, QR code generation, waste data submission, rewards, and complaint handling. We are also using the MySQL for data storage. It is employed to store user details, waste tracking data, complaints, and rewards. We are also using the QR code management. QR codes are generated using QR code and pillow libraries. PySpark is used for decoding and OpenCV handles image capture. For the reward system, it integrates with a UPI payment gateway for cash incentives and promotional rewards for hotels and industries. For the grievance portal, complaints are managed through Flask WTF forms and stored in the MySQL using SQL Alchemy. For the multilingual support, it is implemented with the Flask Payable for static content and Google Translate API for real-time translations. For the chatbot, it is powered by Rasa for dialogue management with Chatterbot for simple responses. NLTK and Spacy enhance NLP capabilities integrated with Flask. For the real-time tracking, it utilizes Google Maps API for tracking the live location of the municipal team. We are also using the various APIs such as Google Maps API for live location tracking and Google Translate API for multilingual support. We are also having a chatbot on our system, and the functionalities of the chatbot are NLP engine, it parses and understands user queries, knowledge base, it provides predefined information, data storage, it holds dynamic data for specific queries, and bot engine matches queries with information and generates responses. We are also using the various dependencies in our system such as Flask for web framework, Flask SQL Alchemy for ORM for database management, QR code and Pillow for QR code generation, PySbar and OpenCV for QR code scanning and image handling, Flask bcrypt for password hashing, Flask WTF for form handling, for Flask Payable for language translation, Google Translate API for dynamic translations, Rasa Chatterbot for chatbot integration, NLTK Spacy for NLP, OpenCV Python for image and video processing, UPI payment gateway for reward distribution. The possible aspects of our system from various domains are technical, operational, economic, social. For the technical domain, we are having QR code generation, database management and API integration, chatbot for user interaction, and grievance portal for registration of the complaint. For the operational domain, we are having collaboration with the municipals, existing waste management workforce, feedback mechanism, community engagement and education strategy. For the economic domain, we are having the cost saving through efficient waste management, job creation, grants or funding opportunities. For the social domain, it improves the public health and environmental outcomes. It also enhances engagement and participation of the users. Through our system, we are able to achieve the various aspects from various domains such as market, financial, scalability, and sustainability. From the market domain, it is also the growing demand for sustainable waste management. Opportunities for partnerships and collaborations are being introduced through the hotels. Increasing force on the circular economy is being generated through the waste reduction. For the financial domain, the cost reduction through efficient waste management routes is being achieved. For the scalability domain, modular design enables addition of new features and integration. For the sustainability, it reduces waste, promotes recycling, and supports community engagement. The impacts we achieve from our system are waste collection based on segregation, chatbot assistance, grievance portal, live location of garbage truck, multilingual support, feedback mechanism, and increased recycling rates. There are also various benefits achieved from our system such as payback and reward system, instant support, easy grievance portal, efficient waste management, broader accessibility, promotion of hotels and industries, and also the job creation, job opportunities are being achieved through our system. Along with the impacts and benefits, our system also provides the various opportunities in various fields. For research and references, we have studied various research papers and take the reference from the various existing systems. So, the first is the Swachh Bharat mission. It was launched by the Ministry of Housing and Urban Affairs. This mission aims to enhance cleanliness and sanitization across the system. The next we have is the SIH Zero system. It is the existing system which is founded with a focus on sustainable waste management. SIH has been a pioneer in developing and implementing effective waste management. This approach and insights have informed the design of our reward system. The next we have about is the Indore Municipal Corporation. It was recognized as the cleanest city in the 2017. Indore's success in waste management highlights the effectiveness of rigorous and innovative waste management practices. So, the images we provided are the real-time survey we did of our local area. In short, I would like to conclude that the zero waste system promotes sustainable waste management by integrating QR codes for tracking, a reward system for segregation, and real time data management. With multilingual support, a chatbot, grievance portal, and live garbage truck tracking, it empowers users to contribute to eco friendly practices while ensuring operational efficiency. Thank you.